Today we're here to talk about what happens to a coffee bean during the roasting process. As roasters, we throw around a lot of terms: first crack, second crack, some people talk about third crack. But coffee is really interesting when you roast it. Coffee is made up of about 800 different compounds after it's roasted. A lot of those compounds form as the coffee beans are roasting. And about a third of those compounds are associated with aroma. So there's a lot of stuff going on with a roasted bean. When we roast coffee, my favorite way of roasting is sight, sound, and smell. And coffee beans tell you a story as they're roasting along. So a green coffee bean is really dense and hard. So let's take a picture here. Let's look at this picture of a green coffee bean. See how small it is? Now look at the roasted coffee beans right beside it. And what you'll see in this picture is that when a bean roasts, it will up to double in size and it'll lose, some of its weight from the moisture, but it's very, very different. So Carrie and I learned a lesson when we started grinding some blonde roast. It still was really, really hard because it was right before first crack and it plugged up our grinder. So it's really dense like a rock. So what happens when the bean is roasting is the first thing we notice is that the chlorophyll and the plant compounds inside of that bean will turn from a green to more of a yellow and then a golden brown. And that's those green plant compounds starting to cook and starting to burn a little bit and change color. As we're roasting along, we see that happening at 280 to 350 degrees. It really turns that golden color. And then we get close to first crack. And if you've heard anybody talk about roasting, they'll talk about first crack. But what is that? What's happening? Well, inside of a green bean, they start out at about 10 to 12% moisture content. So they have, quite a bit of moisture in there. As that moisture expands, it turns to steam at about 212 degrees, and it starts to pool and seek the path of least resistance to get out of that bean. And that happens to be this little seam. So look at a picture of a green bean up really close. You see that little seam down the middle? That's where that steam escapes. When it builds up pressure, when that bean gets to 395 to 405, it's like that 400 degree mark, we hear that pop associated with first crack. And it sounds like popping popcorn. That's what we would associate it with. And that will go on for a while until we get close to second crack. Now, second crack is different. Second crack is a little bit of moisture escaping, because remember, after the bean's roasted, now we're down to about 4 or 5%. But what's happening now is let's look at this other picture. This is roasted coffee under an electron microscope. You see all those little voids there? Those voids start out, it's like a sponge, right, with a lot of little voids in it, and the walls between those voids will break and snap, and that's what second crack is. I like to compare second crack, it sounds like food frying in a pan. It's hard to distinguish any one of the cracks, but it's happening very rapidly. It's because so many of those little voids in there are expanding. So that coffee bean is really, I like to compare it to a compressed sponge. If we were to take a sponge, you know how you hold a sponge in your hand, you compress it down tighter and tighter and tighter, the air escapes, the little voids get smaller. And when that bean expands after first crack, it's like that sponge is released and it puffs up. And now we have all those gases inside of there that are trying to escape. And second crack happens at about 440 degrees. That's when we really hear that start to come on. Those voids fracture. It sounds like it's cracking faster, and then we see something else happening. And what we see happening now is we will see the oils to start to pool. The oil and the sugar get driven out towards the outside of the bean from the inside. The moisture carries them out towards the shell. And if we roast it long enough, we get around 455, 460 degrees, we see that glossy shell, start to form on the beans, and that's the oil and sugar pooling on the outside. If we take it beyond that to an Italian roast, we're going to get it to where it's really black, and then it'll actually start getting duller after that, and a lot of the flavors are leaving, and that's the kind of coffee that I don't make very much. The off-gassing process, now that we've roasted a bean, now it's full of carbon dioxide. Whole bean, we had a lot of questions after our video on coffee freshness. Whole beans take about 9 days to off-gas at room temperature, so they'll stay fresh for about 9 days. In the freezer, you can add 3 days to that. It'll last for up to 12 days. Before it off-gasses. And remember to pack it, vacuum packed in a one-way valve in the freezer. You can store it that way. Now, if we were to grind that bean, it off-gasses in 1 day. So 1 day the flavor's gone. So yes, everything that you buy that's ground in a can is stale when they package it. So that's the scoop on coffee roasting. Hopefully that gives you a little bit better idea what goes on inside of that bean while you're roasting.